Now today we are going to discuss the cleaning of the exhaust gas, controlling the air fluid mixture and controlling the combustion processes and the exhaust gas circulation. Okay, so these are the things we are going to prepare. So see, one more important tip I like to give you all. Abhi, you are there in the yesterday's class? Okay, so I have started the fifth module over here. Okay, so see, in the fourth module and the fifth module, see carefully, listen what I am telling. In both this module, okay, the concept name is changed. Okay, so whatever the concepts are there, their names are only changed, but the diagrams and everything's having the same similarity. Only you have to take it the particular diagram and highlight that particular parts, and you have to explain. Okay, if if a okay, so see, I will give one simple example. So what is an car? Okay, what is an car? Okay, so what is a car? The car having engine, steering, wheels, okay, glass, mirrors, cushioning, beds, everything. Okay, so if you understood the total car, then you can write each and every components over there. Okay, same thing is there in the model number 4 and the model number 5. Okay, so in this you have to understand the complete automotive uh, functions. What is a carburetor, how does it works, okay, and different types of carburetor. If the carburetor working is the same, so in the type of carburetor slightly they have given the changes, okay, in the model number 4. So same way in the model number 5 also the same thing is there. There it is nothing but the emission control system. So emission, okay, what do you mean by the emission? Emission is nothing but the harmful gases which are coming out from the engine, that's are called emitted gases. Okay, or the hazardous gases which are coming out, that are the emitted gases. So which are the gases are coming out? Carbon dioxide, hydroxide, hydrocarbon and nitrogen. So these are the major gases which are harmful to the nature and which are coming out of the engines. So that you are going to study in this fifth module. And what are the different procedures are there for controlling these types of gases, and from where these types of gases are generated. Okay, in the yesterday's class also I have explained the same concept. Okay, today just I am highlighting that one because you have not attended yesterday class. If you I will go with the further concepts you can't understand. Okay, so the previous class is linking with today's class. Now the controlling crankcase emission and controlling the evaporation emission. This is what emission is, what just now I've told from where the gases are coming out. Okay, so the controlling crankcase, what do you know the crankcase? What is a crankcase? So see, the you are putting an engine oil, you are, if you are having a bike or the car, you are putting an engine oils, is it? When you put the engine oil, where that engine oil is going, it is not going in the block and piston, where the piston and is there in the block, where the piston movement is there. Do you all know that? Okay, over there the engine oil is not going, it is reserving in the crankcase where the crankshaft is rotating. Okay, so the when the engine is heated, okay, obviously the heat is transferred to that oil, the oils also start to heat, and from that heated oil some of the gases are coming out. Okay, that gases are also hazardous to atmosphere. If you openly leave that gases outside, okay, this will also harmful gases are there. You cannot release it directly in the atmosphere. For that reason, that gases are been recirculated and used for the combustion purpose. So this is also this is how the controlling crankcase emission is been done. Okay, and the second thing is that if the gases is been collected in the crankcase direct, the crankcase is totally sealed by the packing. If the gases are collected in the crankcase, so what happens, the pressure of an gas will generated within the crankcase, and it can go the make the damages to the engine. For that reason, the gases should be released out from the crankcase. It has been removed out from the crankcase, and once again it has to be used for the combustion purpose. Okay, so this is the control crankcase emission. Now we will go in the control evaporation emission. So say yesterday's class I have explained with the diagrams and each and everything in the detail, but I am explaining you all now shortly because you cannot understand now today's class, that's why. Okay, so the control evaporative emissions, in this what is happening, the each and every vehicle having the fuel tank, okay, petrol or the diesel tank is there from where the fuel is being supplied to the engine, is it? So in that fuel tank, as the engine works for a longer time, okay, or the running of an engine is been at a high speed for a longer time, so what happens, the engine is been heated, or the temperature of the engine is been increased. Once the temperature of the engine is increased, then what happens, the fuel in the fuel tank also be increased over there. Okay, otherwise the fuel in the carburetor will be increased or heated. Okay, once it is heated, the fuel starts to release the vapors. Okay, how the when you heat the water, the how the water vapors are coming out, same way when the fuel is been heated, the fuel vapors may be come out. That vapors are converted into an gases. Okay, for such gases should be controlled, that is called as an emit gases. Okay, so such controlling of such gases which are released from the fuels, okay, that is called as a control evaporation emission. That gases are once again used as a fuel into an engine. Okay, so the for that the plunger plug is there. From that plunger plug, the pressure harmful gases are been released out. That gases are been once again uh, transferred to the carburetor venturi or the throttle valve. Okay, so this everything we have discussed in the last class. Now today in this class we are going to discuss the cleaning the exhaust gas. So whatever the exhaust gas which is coming out, how to clean, and once again it has been reused. And next concept is controlling the air fuel mixture. Over here you can see in your syllabus, controlling air fuel mixture and controlling combustion processes and exhaust gas recirculation. One, two, three, four concepts we are going to discuss in this class. Okay, so whatever the gas which is coming out from the engine after the combustion, okay, that gas has to be controlled. Control means what, it should not expose to the atmosphere. Now you can see in this notes, the automotive engine burns a liquid fuel gasoline which is an hydrocarbon. So when the fuel is burned in the engine, which gas is coming out? Hydrocarbon, made up of hydrogen and the carbon. During the complete combustion, the gasoline produced. Gasoline means what? The gas which is coming out by the when the fuel is burned in the engine into an water vapors and the into an water vapors or carbon dioxide, which are harmless to the atmosphere. Direct the carbon dioxide, if you are releasing in an atmosphere, it is very dangerous, is it or not? So we cannot breathe the carbon dioxide, we want a fresh oxygen for the human beings. Okay, so during harmful to the atmosphere. However, in the automotive engine, the combustion never completed, some unburned gases, so complete fuel is not going to burn in that one. Some of the fuels remains in the engines. Okay, the fuel which is remain in the engine, okay, when the fuel temperature is increases, that fuel is been heated and releasing the gases. Okay, keep in your mind. Then some unburned hydrocarbons and a carbon monoxide forms due to an incomplete combustion of the gasoline. Then okay, so the nitrogen oxide formed due to an high combustion temperature. So the combination of hydrocarbons and carbon dioxide release the nitrogen oxide, which is very harmful to the hazardous. Now these gases, from where it are going to comes out? So these gases are going to come out by the exhaust valve. Okay, so this exhaust valve, then these gases are being used for the movement of the turbine in the what you can say, in the previous module, that is module number supercharging and turbocharging, you have studied in the module number 4, in which these types of gases are being used for the rotation of the turbine and the compressor. First thing, and second thing, you can how it has can be controlled. Either it can be used for the turbine in spite of directly leaving in an outside direct to the atmosphere, then that particular air can be cleaned, or the exhaust gases can be cleaned. How they are going to be cleaned? By the controlling the thermostatic device. There is a thermostatic device by which the gases can be removed. Thermostatic air cleaner is there, by which the harmful gases are being removed out, and once again it has been utilized for the burning of the air fuel mixture. Okay, and also the temperature of that gases has been cooled. Sorry. Then the fuel tank and the tailpipes are there. Okay, then the pollutions engine crankcase. Okay, air cleaner. The pollutants from each of these sources are controlled by the emission control lives by the crankcase emission and the control system. Okay, the crankcase emission control system is also one of the important system by which you can clean the exhaust gas. Evaporation emission control system, just now I've told. So by which you can control the exhaust gas. The method used for reducing the amount of the pollutants in the exhaust gas are controlling the gasoline quality. So the pure gas should be supplied. The air, so see the controlling, if you control the air fuel mixture properly, so that the air and the fuel which is inserting in the engine 100% to not 100%, if you burn, at least burn it for the 99% or the 95%, so the quality of the gases, or the percentage of the gases which are coming out, will be reduced. Okay, the controlling of an air fuel mixture. So see, second point they have given, controlling of an air fuel mixture plays a very important role for the cleaning. So see, 100% you cannot able to stop the harmful gases, just you have to control the percentage. Okay, so this thing is keep in your mind. The controlling the combustion process, so whatever the combustion is happening, the burning of an fuel with an air, that you have to control properly, so that a maximum amount of the air and the fuel can burn. And the threatening of an exhaust gas, threatening means what, whatever the exhaust gas are coming out, that should not be exposed to the atmosphere. If it exposed, so the throttle on fear will be there, so that exhaust gas has been recirculated. Okay, so this is some of the points regarding the cleaning of the exhaust gases. And now controlling the gasoline qualities. Gasoline qualities means what, the whatever the gas in the form of fluid which is coming inside the engine, okay, that you are going to study. Resistance, the if you have not controlled, so what will happen, the resistance of detonation, the spark knocking may occurs. Okay, if you not control, so for that reason, to resist, to stop the detonation and the spark knocking, the gasoline control should be done. Okay, the oxidization inhabitabilities. Okay, avoids the jamming tendency in the fuel system. Jamming tendency means what, the fuel, what you can say, the sticky position of the fuels may occurs if the gas is not properly recirculated. Okay, so these are some of the characters. Once you study, you can understand. Now the controlling the, now let us go with the controlling of an air fuel mixture, which is one of the important concept of your uh, subject. Okay, this one. So see, in the previous class also, in the carburetor, when you study regarding the carburetor, okay, you have study what does the carburetor do. The carburetors control or make the air fuel mixture and transfer that air fuel mixture to the engine. So in what condition the engine required the air fuel mixture? So see, there are so different ratios are there on that, the air and the fuel mixture is to be introduced into the engine. So if the 14/1, so what is the 14/1? 14 is an air, 1 is an petrol or the diesel. It has been transferred to the carburetor in a, by the carburetor to the engine in the normal condition. If the engine is in the cold condition, okay, the atmosphere is cold, surrounding atmosphere of the engine is cold, or it is not started by the 2 or 3 in that situation. So at the initial stage to start the engine, it required the percentage of the fuel more so that the combustion occurs faster. Okay, for that reason, how does the air fuel mixture is to be controlled? It is to be controlled by 13 by 4, 4 by 4 or 5. That means what, the percentage of the air is less and the fuel is been more. Okay, this ratio is to be maintained. Now the next, what is the next ratio? When the engine is at an idle condition. Idle condition means what, the engine is in not having the load, in a neutral gear. Okay, the engine is running but the accelerator is not operated, or the engine is not having the load. That means what, the wheels are not rotating only, but the engine is reciprocating or in a working stage. That is called as an idle condition. At that moment the air fuel mixture ratio should be maintained. How much it should be maintained? In a normal ratio, that is a 4:1, 4:3, 4:4. So this is what the common air and the common fuel is been introduced in the engine. Okay, so this is all the some of the condition on what basis the air fuel ratio is been maintained. Okay, and it is maintained by the carburetor, and it is been inserted by the help of the injector into the engine cylinder. Now the fuel air fuel ratio I have told. Now when there is a winter season or the atmosphere is very cold of the surrounding, at that moment you required and fuel percentage more. Okay, and air percentage should be less so that the maximum fuel can be burned. But one more thing is that in these conditions, okay, the air which is supplied to the engine by the means of choke carburetor through the engine, that should not be in a cold form. Okay, keep in your mind, from where the air is coming out by the means of air filter from the surrounding atmosphere, the air is being sucked. Okay, and it enters by the air filters. Filtered air enters by the means of choke into the carburetor. Okay, from the surrounding, whatever the atmosphere you are there, obviously the atmosphere is cold. The air which is sucked by the choke or the engine, or air which enters in the carburetor, obviously it will be also cold. Okay, if the cold air is passed in the engine, so the fuel percentage or the quantity of the fuel which is going to burn or the combustion becomes very less. For that reason, what has to be done, that whatever the air which is going to enter into the engine, it is been preheated. Preheated means what, it has been advancedly heated, then the hot air is been released into the fuel. This is the first thing. And the second thing what they are do, so whatever the second thing is in this design is that the whatever the hot gases which are coming from the engines, that has been taken uh, for the taken in a carburetor. Okay, that hot gases and the pure cold gases are being mixed. Okay, by which the temperature of the pure cold gases increases and it is allowed to enter into the engine. Okay, by which the hot air with then fuels can burn inside. Okay, uh, which helps the fuel to burn. Now I will share you some diagram. On that basis diagram we will study how does this hot fuel gases are mean work, and what is the main this one part is there which has been used for making the air fuel mixture rich. Okay, by releasing the hot gases during the warm condition. So this is one important thing. Okay, 1 minute I will see that. Automobile emission system. Now see, this is what you can see in this diagram. This is one device which is called as an thermostatic air cleaner. Okay, thermostatic air cleaner. So it is been used for you can say for preheating the fresh or the cold air. Now you can see in over here. So you can see over here there is an inlet port is there from where the cold gases enters in this thermostatic air cleaner. From over here it converted into and some of the hot gases and enters into the engine. Now let us see the working, how does it works, and what are the. Now you can see the construction. This is the clamp or the cover. So if you have seen any Fiat cars, old Fiat cars or the ambassador cars, okay, over there engine, if you can see, open that engines, on that engines you can see this thermostatic air, okay, Fiat or the ambassador cars. Now inside this there is an air filter is there, thermostatic wall is there, then this is a PCV filter, vacuum housing is there. From over here you can see the air intake, and this is the collar and the shutter. So this is what the 3D diagrams of this thermostatic air filter. Now before going through this, I will share you this diagram. Okay, in this diagram there are three. This is an 2D diagram is there. In this 2D diagram, in these slides you can see the four different positions are there. This one, 2, 3 and 4 different positions have been shown in this diagram. Okay, so before going to this you can see the construction over here. So I will share the notes. Okay, in that you can see the 2D diagram clearly. Just I have drawn this diagram, okay, taken these slides for the reference purposes. In this so this type of thermostatic air cleaner, it can be used in the diesel or the petrol vehicles. Okay, but the use of this one is that in the cold condition to start the engine by supplying a hot air fuel mixture to the engine. This you have to keep in your mind. Now you can see in this condition over here, there is a diaphragm is there. That diaphragm is connected. Diaphragm means what? A spring piston is there, okay, which is going to be lifted up by the pressure and which is going to lift down by the when the pressure is released. And here is an air bladed wall is there, okay, from where the temperature sensor is been fit over here, as well as the spring is there. This side the spring is there, but once the diaphragm opens up, okay, obviously the air beaded wall also opens, okay, and by from where the hot gases are being released out. Now you can see also see the this one, okay, temperature sensor is there from where the hot gases is been released out. Now at the bottom you can see over here control damper assembly is there. Damper assembly means what? It is just like an one small wall is there, okay, when the hot gases are coming from this side, that is an from the engine, it is connected to the engine from where the hot gases are coming from the engine. If the pressure is increased, it will lift it up. If the pressure is decreased, it will lift down. Okay, so this is what the simple construction. Now let us see the four stages, when does it works. Okay, the first is an under hood temperature below 29 degree Celsius. So below 29 degree Celsius means what? It is a cold temperature, okay, cold condition in which the engines require the hot air plus fuel mixture. okay, that is an air and fuel mixture combination to the engine, so that the fuel can burn in a maximum percentage. So from over here, inlet for the outside air, okay, from over here the inlet air is coming inside, okay, so it is very cold air is coming out from the atmosphere, okay, where your bike and car is there, surrounding climate is cold, so from that atmosphere the cold air is entering from this side, okay. When this cold enters, okay, at that moment what happens, from the engine the hot gases are being passed from this outlet port, okay. When the gas pressure is increased over here, at that moment what happens, this control damper assembly is there, it is been opened, and this cold and the hot gas mixture mix with each other, and that hot gases makes the cold gases to convert that temperature into hot or the high temperature. Then this air bladed valve open ups, has the diaphragm opens and allows that hot and the cold gases to pass over there to the carburetor, and with the fuel it gets enter into the engine. Now in the second diagram you can see, this is the second diagram, that is nothing but the second condition. In that second condition, this is an alternate close. I will open 1 minute, I will show you. Now you can see over in this second diagram, this is an uh, above closed diagram means what? In this diagram you can see, when the engine is in hot condition or the continuous running of that engine is there in the hot condition, it doesn't require the hot air fuel gas. The normal normal air which is passed to the engine, obviously it converted heat inside that one, or the temperature of the outside is above 53 degrees Celsius, or the engine is above 50 degrees Celsius, so only the cold gases are being passed out to this one. No damper assemblies, no wall damper wall is opened over here, only the cold gases are passes. Now over here you can see over here, this is an partially opening means what? Under the temperature below 29 and 53, okay, when there is a normal temperature, at that moment what is happening, continuously the hot and the cold gases are being supplied to the engine, okay. So this is how the controlling of an air fuel mixture is being done in a thermostatic air cleaner method, okay. And otherwise you can draw a 2 or 3 carburetor diagrams and show the explanation how it has been controlled by showing the difference ratio of the air fuels, okay. Now we'll go with the next slide. Oh, sorry. Now this is an how the exhaust gas which is coming out from the engine, okay, recirculation works. So how the exhaust gas which is coming off the engine, which can be recirculated, or that gas can be reused in the engine, that we are going to study, okay. Now what is the necessity of that gas to be recirculated, and the advantage of the gas which is to be recirculated, construction and the working, that we are going to study. Now see the necessity, the reduce the engine heat losses by limiting the maximum temperature, okay, the relative low vehicle emission to and accomplish within the emission norms. So these are the two major points or the requirement for which the exhaust gas recirculation should be done. Okay, so the gases which are been exhausted from the engine, in that the major gas is an carbon dioxide. Okay, so what does the carbon dioxide does? So see, for the burning of in putting in fire, obviously the oxygen is required. Without oxygen you cannot burn anything. Okay, same way, to reduce the temperature, okay, in spite of oxygen, where there is a fire, if you produce an carbon dioxide, so that fire burning will stop over there. Is it? Is it or not? Okay, so like this way, the advantage of this carbon dioxide is been taken in such a way that this carbon dioxide is once again, which is coming out from the engine. So from this part I will show you. So this is an exhaust from where the carbon dioxide is coming. Okay, that carbon dioxide, once again it has been utilized in such a way that carbon dioxide is being passed once again to that engine, so that the temperature of the engine is been reduced out. Okay, once the temperature of the engine is been reduced out, okay, or make in a control, so the emission percentage will be reduced relative to a low vehicle emission. Okay, so the really emission percentage will be reduced, okay, by the temperature releases out. This one is the first thing, and second one is that the carbon percentage which has been coming out as an emission, which has been also been controlled. So this is why it is a requirement that whatever the gas which is coming out has to be recirculated. Now how it is been recirculated, that you are going to study, and this is a simple normal setup is there on which basis the gas has been recirculated. Obviously there is an engine is there from where the exhaust gas is coming out. One gas is going for the catalytic converter, that is a material converter. Then I will tell you what is the catalytic converter does. From this catalytic converter it is transferred to the turbines, from the turbine where the compressor or turbochargers works. Then another connection is given to the EGR valves. EGR valves are nothing but gas. EGR valves are nothing but exhaust gas recirculation valves. Okay, exhaust gas recirculation valves. From over here, this uh, gases, that is in carbon dioxide, enters to the throttle valves, and then once again with a mixture of an air fuel it enters to the engine. So this is what the simple construction. In the next slide I will show the working, how does it works. So see, the exhaust valve actual by the manipulated vacuum. Okay, and the exhaust also opens around 2000 to 2500 to 3000 rpms. Okay, so see, when this exhaust valve works, and what time does it what you can say release the carbon dioxide. So see, the when the engine is running at an high speed, that is in 2500 rpm to 3000 rpm, at that moment the movement of the piston within the block is very high, the strokes speeds are also very high, the wall timing is also very high. So at this moment the fuel which is, there are so many possibilities to the less combustion of the fuel is to be done. Okay, or some of the fuel is been left by the burning. This is the first thing. And the second thing, the temperature of the engine is increases. Okay, so because of the high temperature, the engine is running at an high rpm, the fuel which is not burned inside this engine has been starts to evaporate the gases, as well as the burned fuel also starts to evaporate the gases, as well as from the crankcase the oil is also heated, it also starts to release the gases. So all these gases, okay, including the carbon dioxide which is released in the high percentage, is been starts to come out from the exhaust valve. From this exhaust valve, at that moment what happens, Okay, this everything is controlled. Now the hybrid guards are there, electromechanical units are there for controlling this one. This exhaust gas are being entered in an EGR valve. From this EGR valves, the pressure is being controlled, or these valves are open at an high speed of the engine, or by which it releases the high pressure gases from the exhaust. Okay, the so obviously the engine is moving in a faster rate, so the movement of the valves will also move in the faster rate. So the continuous movements of the opening of the valves, either it may be the inlet, either it may be the exhaust. Okay, if you consider the exhaust, so the gas movement or the gas which is coming out of that engine will be in a faster rate. So the amount or the of the gases which is going in the catalytic converter is also going, but the percentage is been increased, so the remaining gas is been diverted to the EGR valve. From that EGR valve it is been transferred to the throttle, where it mix with the air fuel mixture. Okay, fresh air, okay, as well as the fuel, and this hot gases, both the hot and the cold air mix with each other. Then the cold air try to reduce some temperature of the hot gases, or adopts the same temperature with the fuel mixed with each other and enters into the engine. This is how in the simple working I have tried to explain you that exhaust gas recirculation system. Okay, so this is of the concept exhaust gas recirculation system we have done over here. Okay, so by this today's class we will be wind up. Okay, in the next class we will go with the air injection system, threatening exhaust gas, and air respiratory systems.